Some students told me that this question from Chemical Calculations Workbook is quite difficult. So today in this video I am going to break it down step by step. If you are new to this channel, I am Amila Senadeera. I am the founder of amila.guru. I am a chemistry educator, author and exam coach. I help A-level chemistry students understand chemistry in a clear and structured way. If you are looking for a one-to-one chemistry coaching, you can book a session. Just WhatsApp me at 07171911626. Now, with that said, let's move to the question. This question is on page 14. In the right hand side, it has clearly mentioned that principles and theories required to write the answer to this question. So first, let's consider about them. First one is write balanced chemical equations for thermal decomposition of compounds. So what are the compounds? The compounds are sodium carbonate, sodium bicarbonate and hydrate of sodium carbonate. We know that sodium carbonate is thermally stable. Then what about sodium bicarbonate? When we heat sodium bicarbonate, it decomposes to sodium carbonate, carbon dioxide and water vapor. Then what about the hydrate of sodium carbonate? It decomposes to anhydride of sodium carbonate and water vapor. So we can balance these reactions like this. Then second one, the relationship between number of moles, mass and molar mass. We know that number of moles is mass over molar mass. The molar ratios between the species when a reaction takes place. So we know that when there is a balanced chemical equation, we can write molar ratios according to that balanced chemical equation. So if we know those things, we can write the correct answer to this question. Okay, let's write the answer step by step. So what is the first step? Write balanced chemical equation for the reactions that take place on heating the sample. So we don't need to write about sodium carbonate because it is thermally stable. Then we can write about sodium bicarbonate. When sodium bicarbonate decomposes, products are sodium carbonate, it's a solid, carbon dioxide, it's a gas, and water vapor. We can balance the reaction. Then hydrate of sodium carbonate. When it decomposes, products are sodium carbonate, it's a solid, and water vapor. Okay, then there will be a problem. How can you know these reactions? When we do calculations in chemical calculations lesson, we may come across these reactions. Then we need to remember those reactions. Some of these reactions will be taught during inorganic chemistry. When you notice a new reaction, try to remember that reaction. What are the reactants? What are the products? Then it is easy to do these kind of calculations. It's necessary to remember products and reactants of some reactions. So it's better to remember those reactions. Second part, calculate the number of moles of carbon dioxide formed on heating the sample. So in the question, it is given that 3.69 grams of water vapor and 0.22 grams of carbon dioxide were obtained. So we can calculate number of moles of carbon dioxide formed. So how to calculate that? Number of moles is mass over molar mass. Mass of carbon dioxide 0.22 grams. Molar mass of carbon dioxide. Molar mass of carbon dioxide is 44 grams per mole. How did I write like that? Because I have done many calculations, therefore I can remember the molar mass of carbon dioxide. If you couldn't remember molar mass of carbon dioxide, carbon 12, oxygen 16, 16 times 2 32, 32 plus 12 44. So molar mass is 44 grams per mole. Grams, cancels out, answer is in moles. 0, then 2, there are no 44s in 2, 0, then 22, there are no 44s in 22, 0, 220, there are 5 44s in 220, 5 times 44, 220. So this is number of moles of carbon dioxide formed during this thermal decomposition. Then calculate the number of moles of sodium bicarbonate present in the sample. So when we consider these thermal decomposition reactions, only the thermal decomposition of sodium bicarbonate forms carbon dioxide. Therefore, we can calculate number of moles of sodium bicarbonate using number of moles of carbon dioxide formed during that reaction. So what is the mole ratio? 1 carbon dioxide mole to 2 moles of sodium bicarbonate. So we can calculate number of moles of sodium bicarbonate present. It is 2 times number of moles of carbon dioxide, 0.005 moles. 5 times 2, 10, 3 decimal places, 1, 2, 3. To write the answer to that step, we used mole ratios. Fourth part, calculate the mass of sodium bicarbonate present in the sample. So how to calculate mass? So we know the relationship between number of moles and mass. Number of moles is mass over molar mass. We can multiply both sides by molar mass. Then mass is number of moles times molar mass. So we can calculate mass of sodium bicarbonate present. Number of moles 0.01 times molar mass. Molar mass of sodium bicarbonate is 84 grams per mole. So how did I write that? The same reason, I have done many calculations, therefore I can remember molar mass of sodium bicarbonate. If you couldn't remember molar mass of sodium bicarbonate, sodium 23, hydrogen 1, then 24, carbon 12, 24 plus 12, 36, then oxygen 16, 16 times 3, 48, 48 plus 36, 40 plus 30, 70, 6 plus 8, 14, then 70 plus 14, 84. 1 times 84, 84, 2 decimal places, 1, 2 moles per mole. So answer is 0.84 grams. that is the mass of sodium bicarbonate present in the sample. Then fifth one, calculate the number of moles of water formed by the decomposition of sodium bicarbonate. So we know number of moles of sodium bicarbonate decomposed, and we know number of moles of carbon dioxide produced during that decomposition. Therefore, we can calculate number of moles of water vapor produced during that decomposition reaction. So we can write number of moles of water vapor formed by decomposition of sodium bicarbonate. So we can use mole ratio between carbon dioxide and water vapor, or mole ratio between sodium bicarbonate and water vapor. So let's use mole ratio between carbon dioxide and water vapor. Mole ratio is 1 to 1. That means same amount. So number of moles of carbon dioxide formed 0.005 moles. Therefore, number of moles of sodium bicarbonate produced during this thermal decomposition should be 0.005 moles. Or you can use number of moles of sodium bicarbonate also. Then mole ratio is 2 to 1. That means half of number of moles of sodium bicarbonate. That means 0.01 moles times half. The same value 0.005. So in this case I used the mole ratio between carbon dioxide and water because that ratio is 1 to 1. Then it is easy to determine the number of moles of water vapor. Then sixth part, calculate the number of moles of water vapor formed when sample is heated. So it is given that mass of water vapor is 3.69 grams. So we can calculate number of water vapor formed. So how to calculate that? Mass over molar mass. Mass of water vapor 3.69 grams. 3.69 grams over molar mass of water. It is 18 grams per mole. If you couldn't remember that value, then you haven't done enough chemical calculations. So please note that very carefully and do as many calculations as possible in chemical calculations lesson. So for that you can refer to my chemical calculations workbook, or you can use chemical calculations past paper discussions. Then grams cancels out, answer is in moles. There are no 18s in 3, 0, then decimal place 36. How many 18s are there in a 36? 2. 2 times 18, 36. Then 9. How many 18s are there in 9? 0. Then we can put a 0. 90. How many 18s are there in 90? 5. So 5 times 18, 90. So number of water vapor formed during this thermal decomposition is 0.205 moles. But from that amount, 0.005 moles were produced from the thermal decomposition of sodium bicarbonate. So the rest is formed by the thermal decomposition of sodium carbonate. So we can calculate number of moles of water vapor formed by the decomposition of hydrate of sodium carbonate. So this is total number of water vapor formed, 0.205 moles, minus this is the water vapor formed by sodium bicarbonate, 0.005. So that is 5 minus 5, 0, 0 minus 0, 0, 2 minus 0, 2, decimal place 0. So then we can calculate number of moles of sodium carbonate present in the sample. We can consider the mole ratio between water vapor and sodium carbonate hydrate. So we can write number of moles of sodium carbonate, hydrate of sodium carbonate. So what is the mole ratio between water vapor and hydrate of sodium carbonate? It is 10 to 1. That means we need to divide the number of moles of water vapor formed by the decomposition of sodium carbonate hydrate by 10. So when we 0.2 moles times 1 over 10, that means 0.02 moles. I think the procedure is clear. This is the total number of water vapor formed during this thermal decomposition. There were certain amount of water vapor formed by the thermal decomposition of sodium bicarbonate and certain amount of water vapor formed by the thermal decomposition of hydrate of sodium carbonate. Therefore, we know the total number of water vapor formed and we know the amount of water vapor formed during the thermal decomposition of sodium bicarbonate. Therefore, we can calculate the number of moles of water vapor formed by the decomposition of hydrate of sodium carbonate. Then calculate the initial mass of hydrate of sodium carbonate. So mass of hydrate of sodium carbonate. So how to calculate that? Number of moles is mass over molar mass. We can multiply both sides by molar mass. Then mass is number of moles times molar mass. Number of moles of hydrate of sodium carbonate is 0.02 moles times molar mass of hydrate of sodium carbonate. It is 286 grams per mole. Because I have done many chemical calculation questions, I can remember that molar mass. If you couldn't remember that, you can add sodium 23, 23 times 2, 46, carbon 12, 46 plus 12, 58, oxygen 16 times 3, 48, 58 plus 48, 50 plus 40, 90, 8 plus 8, 60, then 90 plus 16, 106. 10 water molecules, 10 times 18, 180. 180 plus 106, 286. So 2 times 286, 12, 7, 5. How many decimal places? 2. Moles per mole, answer is in grams. So we know the initial mass of hydrate of sodium carbonate. We know the mass of sodium bicarbonate. So there were 3 compounds: sodium carbonate, sodium bicarbonate and hydrate of sodium carbonate. Total mass was 23.52 grams. We know mass of sodium bicarbonate, we know mass of hydrate of sodium carbonate. Therefore, we can calculate mass of sodium carbonate. in the initial sample. Mass of sodium carbonate. So total mass was 23.52 grams. Then mass of sodium bicarbonate. Mass of sodium bicarbonate present in the sample was 0.84 grams. Mass of hydrate of sodium carbonate 5.72 grams. 23.52 grams minus 8, 4 plus 2, 6, 8 plus 7, 15, 1 remains, decimal place, 0 plus 5, 5 plus 1, 6. So 2 minus 6, we need to take 1 from here, 12 minus 6, 6. There is 4. 4 minus 5, we need to take 1 from here, then 14 minus 5, 9, decimal place, 2 is there, 22 minus 6, 60. 16.96 grams of sodium carbonate were there. So that's how you should write the answer to that question. The chemical calculation workbook is structured like this. So first you need to write principles and theories required before writing the answer to the question. So if you can remember those principles and theories, then you can try to write the answer to the given question. If you couldn't remember principles and theories required to write the answer to that question, don't write the answer. Check your theory notes and study those principles and theories. Then when you are familiar with those principles and theories, start writing the answer to that given question. So after writing, you can check the given model answers in the book. Those answers are in the later part of that book. So if there is any confusion, always you can message to me 07171919626 about those confusions. Then I can help you to resolve those confusions. So there are 25 structured essay type questions in this workbook, and additionally there are 50 bonus MCQs, and descriptive answers are given for those 50 MCQs in that book. So if you are struggling with chemical calculations, this is the book that you should refer. If you want to grab a copy from this book, the link is in the description. So follow that link and grab your copy. If you found that this explanation is useful and helpful, please like it. Let's meet in another video like this.